It's going to be a pretty short screencast of Unit 6A. This is Part 3, Soil Nutrients and the Soil Layers or Horizons. So for pH, most soils range from 4 to 8. The soil of the pygmy forest in California is super acidic. In Death Valley, California, it's super basic. Those are extreme cases. You still have plants that live there. However, the happy medium for a lot of plants is around 6.5 to about 8. Proper pH directly affects the availability of plant food nutrients. So if it's too acidic or too basic, the soil, the compounds won't dissolve into water. The plant will not be able to take up those nutrients, and the pH allows the presence of certain ions. Okay, so if soil's too acidic, you can add some limestone into it. If soil's too basic, you can add organic material like cow manure. When you're thinking about acidic soil, think of your acid mine drainage. We were doing the same thing. You add lye or limestone to increase the pH of it. Soil nutrients, macronutrients are larger in atomic structure. Your nitrogen, phosphorus, potassium. Those are our three main soil nutrients that we use to fertilizer. Your micronutrients are smaller: selenium, zinc, iron, sulfur. Plants still need these, but in much smaller amounts. Back to our nitrogen cycle. So the reason why plants need nitrogen, the reason why we need those nitrogen-fixing bacteria, is because your nitrogen is really responsible for the greenness in your plant. So it stimulates your above-ground growth. It influences your quality and your protein content of fruit. So nitrogen is really important for so many crops. And if that nitrogen isn't there, a lot of times the plant can't take up other elements. So this is replenished naturally by those rhizobium on legume roots, also sometimes letting the fields lie fallow, meaning you're leaving them alone for a season. All different things can grow on, can actually fix nitrogen into the soil. The way that we can also add it is fertilizer from manure, which would be an organic method, or from chemicals, usually inorganic. Phosphorus. As you guys know, phosphorus does not have an atmospheric component to it. It does not cycle through the atmosphere. It's mainly found in rocks and in different types of bird poop. So most fertilizer is made from phosphate with rocks. And the reason why we need phosphorus is for a strong root system, your increased seed and fruit development, and part of the root that's involved in water uptake is the hairs, and without your phosphorus, you're not going to have that strong root system for the hairs. Potassium. Potash is what we call it, and I have no clue why we call it potash, and also the chemical symbol for it is K, so it's just all weird. It's important in vigor and vitality of the plant. It carries the carbs through the plant, improves the color of the flowers, the quality of the fruit, and this can offset too much nitrogen. If you have too much nitrogen, what's going to happen is, let's say you have tomatoes in your garden. Your tomatoes are going to grow super tall and green and bushy, but they're not going to produce a lot of fruit. You add a little bit of potassium, it negates that nitrogen, and what happens is then, wha-bam, you start getting tomatoes. It's found naturally in feldspar and mica rocks. Okay, potassium is something that is usually found in rocks and minerals. This brings us to soil horizons. And soil horizons are just layers of the soil. So if you see in the picture here, you have the O, A, E, B, C, and then a solid parent material of the bedrock. And sometimes we call this layer R. Sometimes we call it not R. Okay, so your O is your organic material, that's your top. Then you have your topsoil, which is really the stuff that you're getting in to really plant. And then you have your E layer, which isn't always present. Sometimes you see it talked about, sometimes you don't. And then you have a lighter color subsoil, and then your weathered parent material, where your kind of rocks are breaking apart and then becoming soil. Remember that parent material we talked about before. So O is rich in organic material. Plant litter accumulates here. In desert, there is no O horizon. There is no decomposition. Here in the temperate deciduous forest, we have a huge O horizon, and that's because of the leaves that fall every single fall. Your topsoil, dark, rich in accumulated organic matter and humus. Okay, you're decomposing plants and materials, that kind of composty type of stuff. and it's granular. Sometimes it's nutrient poor towards the bottom, but it's nutrient rich towards the top. And then your subsoil is basically your nutrients and your minerals have kind of leached out of this area. Some litter accumulates. You can see a distinct color shift when you get to your B layer. You want your topsoil to be a pretty thick layer, but in a lot of places, your topsoil isn't actually that thick. And in the temperate deciduous forest, we have a pretty thick A layer. And then our B horizon, a lot of times can be some sort of a clay or a more of a sandy soil that's usually a reddish color. Okay, rich in iron and aluminum compounds, clay. There we go. And then your parent material is your C horizon. And here you can see, okay, like I was saying before, this is basically your interface of where your bedrock is breaking up through, whether it's chemical or physical weathering, and you get this kind of rocky area here. And then you have underneath your bedrock, mostly in this area, your roots won't go down this far. It's often saturated with a lot of groundwater. Sometimes the bedrock is saturated with groundwater, and then your bedrock is sometimes known as your R layer. So if you ever see that, your R is all the way down the bottom.